We're doing problems 1 through 5 on review day 12. First one gives us a graph of a function f, and then we're given an equation g, which is equal to this right here, and we're asked what g prime 2 is. So it's a quotient rule problem. We got to take the derivative of g, which would be the bottom times the derivative of the top, minus top times derivative of the bottom over bottom squared. All right, so that's our derivative of g. Now we want to know what's going on at 2. So g prime of 2 would be f of 2. So this is f. At 2, the function is equal to 3. So 3 times 2 times x, which is 2, minus 2 squared plus 1 times f prime 2. So f prime 2 would be the slope of this line. So I can see that this line went from -5 up to 7, so that's up 12 over 3, so it must have a slope of 4 over f of x. Now again, f of 2 was 3, so that'd be 3 squared, which is 9. So now let me do it. This is going to be 12 minus 20 over 9. And that gives us a -8/9, which is A. All right? So a little quotient rule, and you got to be a little careful with that graph, but otherwise pretty easy one. Second one here gives us an integral from -1 to 1 of this right here. And so what we want to do is try to split this up if we can. And so if I split it, I'm going to get x minus 1. All right, and then I'm doing that from -1 to 1. So if I do that, I'm going to get x squared over 2 minus x from -1 to 1. And if I put that in, I'm going to get 1/2 minus 1, so -1/2, minus 1/2 plus 1, 3/2. -1/2 minus 3/2 is a -4/2, or a -2. So I get A for my answer. This one here gives us a table, and it says for which subinterval must the derivative equal 2. So this must thing, but whenever it says when must the derivative equal, we're thinking mean value theorem. And with mean value theorem, then we're thinking average rate of change. So if I look at my first one, 0 to 8, that's -8 divided by 4 would be a -2. We're looking for +2, so not that subinterval. From 4 to 8, 2 minus 0, 2 divided by 4 would be 1/2. We're looking for 2. From 8 to 12, it's 10 minus 2, 8. 8 divided by 4 would be 2. So that one works. And then the last one, 1 minus 10, -9 divided by 4. That doesn't work. So C would be our choice on that. Number 4 here gives us the limit of this. So if I were to put this in, I would get 0 over 0, because that would be 1 minus 1. So as soon as I see a 0 over 0, I'm thinking L'Hopital's rule. Take the derivative of the top, take the derivative of the bottom, try it again. And if I do that, I get 1 over 1, which gives me an answer of 1. So not too bad. Just have to know L'Hopital's rule. All right, and then number 5 here says a particle moves. It has an acceleration of 12t. Tells us the velocity at t equals 0 is 2, and that the position is 5. So they want us to build a position function out of that. So what we have to do is we have to integrate. So if I integrate the acceleration, I get 12t squared over 2. That's 6t squared plus something. So if I were to put 0 in for t, I'll get 2 for my velocity, right? So that means c equals 2. So my velocity equation would be 6t squared plus 2. All right, now to get my position equation, I'm going to integrate this. So this will go 6t cubed over 3. That'll be 2t cubed plus 2t plus something. We're told our initial position is 5. So when I put 0 in, I'll get 5. All right, and if I look at my choices, that's option D. All right, so not too bad.